Is that earth crimp just supposed to fall off like that? This is my Wago WM250V 3-phase infinitely variable lathe. Came with a 3-jaw chuck, 4-jaw and a faceplate, and I absolutely love it. But could it be improved? I was going to say that. Hey, welcome back to the workshop. So this is episode 3 of installing this electronic lead screw. So this is the one from James Clough, Clough42. If you're watching this, I'm sure you're aware of who he is. I'll put links to his video series, his GitHub where you can download the software, because he's covered this very thoroughly. So while we're over at the lathe, I've definitely made some decisions about how it's all going to be laid out. So I've got this cover here. I'm definitely going to open this up, probably at the bottom here, and make sure I can get the display in here. Now the thing is, as you can see there, it's curved and the display is flat, so I've got to work out how best to do that. If I had a 3D printer, it'd be quite nice just to machine this round part on one part and have a flat, basically make a boss, I guess, with a curved surface. I guess I could machine it out of aluminium, do a 3D toolpath. It might be a bit wasteful, but that's one way to get it done. Don't know, I'm thinking of options, but definitely want the control there because I'll have the RPM there, then I'll have all the buttons and everything sort of here, and then I'll keep the potentiometer, that's this one here, there, because that works really well. So I'm definitely going to do that. In terms of the encoder, not quite worked out exactly where I'm going to have it, but obviously I've got to pick up off the spindle somewhere. And then in terms of the stepper or servo, I'm pretty much decided now I'm going to go for this servo, and it's the one with the integrated driver on the back of it. Now it does end up being a little bit larger, and that means there's no way I can fit it in here, because one of my options was to put it into here. Now I've got all this space, drill a hole through here for the shaft to go through, but it's far too long, plus when the shaft sticks out, the pulley that went on the end would have to stick out quite a long way. I'd have to make a shaft extension to pick up on the lead screw that's down here, which didn't seem like a very good idea. So that's out. So still not exactly sure where I'm going to put it. I can't put it where James put it, because in that main plate, because I've got the inverter in here, there's a factory installed big fan there, the inverter's in there, there's just no space around the back on that side plate. So still thinking of options. So I may go with a suggestion from one of my viewers, which was to put the motor on the side here. I'd need to cut a hole in the cover, but I'm quite liking that idea. So we'll wait till the motor finally arrives from China and then have a look into that. But for now we need to get the spindle encoder mounted. Okay, so we need to make the spindle encoder bracket now. So this is the spindle encoder itself. So what I decided to do is pick up off those three, I think they're M3 tapped holes, and then this bracket here will screw onto there. We'll go into a bit of a pocket, and then because it spans out here, and then there'll be two standoffs, that allows me to put the pulley in here, and then the belt can come in and out, and then those standoffs will mount it to the machine, so it'll sort of sit like that, and then the belt will go around like that. That's the basic idea. So you can see some of the features in here. So there'll be a pocket in the middle that the encoder will sit into, so you can see that they're on the ISO view. Then 3 clearance holes, so we can screw through those. If I've got some countersunk screws, then I'll use those on the other side to keep it flush. If not, I'll just use some mushroom ones, because I think I've got enough space to put those in without interfering with the pulley that goes on there. And then the slots here are obviously to tension the belt, so we can slide it backwards and forwards in 2 places. And then there's a little U cut out at the top. The idea is that the cable, this cable that goes around here, I don't want it flapping or getting caught in the belt. So that will come out of there, into there, and then you can see on the top here, so in the top there I've just got the 2 little M3 tapped holes. There'll be like a closing cap, and the cable will be held in there and then off to the machine. So it's just a local clamp really. Why not machine it in while you're here. And I think the rest of it just sort of cosmetic really, and making sure I cut back enough so that I don't get too close to the main spindle. There's a big drive pulley nearby, so just make sure I've got maximum clearance to that. So I think that's about it. Okay, so we've got the stock on the CNC machine. I've picked up off both edges and got it centered as best I can. We'll just see how we get on. It might be really close, it might leave a little bit of stock, but that's the only piece I've got. Also with this, it'll give me a chance to try out the new mist coolant system and see how we get on. Hopefully we'll cut a lot better with that. Although for those of you who follow the channel, you'll know this spindle is on its last legs. It's it's pretty broken and poorly, so that's a project for the list as well. But for now, let's see how we get on, and we'll cut this piece out. Okay, so I've got the part cleaned up, it's in the vise there. We're just going to put some little countersinks so the countersink screws are slightly flush or underflush to the surface, and then it'll give us maximum clearance to the pulley. Okay, and after all the machining, a little bit of a clean up, and we've got that, so that looks okay. So see the countersinks on there, and the pocket there, and then the little slots to adjust the tension, and then that's where the cable guide will go through there. I was going to make a sort of closing piece that went on top there, but actually it's a pretty tight fit on the cable itself, so it will just snugly go in there, and then it will be clipped the rest of the way, so I think that will be okay. Right, so let's try it out. So first of all, is it a good fit? So let's undo this so it doesn't keep dragging. Okay, so yeah, a bit of clearance on there, and the holes line up. Right, let's put the screws in. All right. There we have it, and then the cable will clip into there, and then the little post that goes along here, I decided it will just clip along there, so I think that's going to be okay as it is. Alright, so speaking of posts, we need to go on the lathe and make those. Okay, so I've got this bit of stock here. I know it's a bit large, but I wanted 12mm, but it's all I got, so we'll just turn this down and then bore a hole through the middle, and we can make the spaces from that. What's happened here? Sorry, while you're machining those parts, I stripped it down and got a bit carried away. You're telling me? Yeah, sorry about that. Well, I guess while we're here, we'll tidy this little lot up and get it working again so we can make some parts. Okay, so what we've got here then, so it looks like these are the lockout. So when you remove that side cover, this came undone, and then it stopped the machine, or stopped you starting it. Okay, so that went through there, that went through a hole in the side, but I've just put my finger on that and there's a razor sharp burr at the bottom. Now, they had sleeved it in this as it went through that hole, but as you can see, it's got little indentations and marks. I mean, I don't know what that's all about. So I think what I'm going to do, sort of throwing caution to the wind, is if these two are together, the lathe will run. Now that just means if I take the end cover off, it is theoretically possible for me to start it, but you know, it's my machine, I'm not going to do that. So, and I think eventually these would have worn through on that sharp edge, even through that, and then the machine would have been live, because I think this is the live feed. As long as you've got continuity through this and the e-stop, then the machine will run. So I'm going to crop these off, probably put a Wago on there, join those, tuck that away down there, worked out the way, and that will be job done. So there's that one. These two, or the feed to the power supply that ran the RPM. Now I'm not going to use that because the new display that James has developed has got an RPM reading on it already. So I think again what I'm going to do is crop those short to about here, because if you remember, these were running underneath the spindle down here. You know, they would have, like the cable that's already there, they would have rubbed through. So I'll crop those off, put some Wagos on those so they're safe, and drop them down here. There's quite a nice void here for those to live in. Maybe heat shrink them as well for good measure. And I think I'll be a lot happier with the electrics then. Okay, time to button it all up. Oh, what? Can you see that? Oh, does not look very good. Oh, it's only the main power supply. Right, let's remake that. Right, so before we go too much further, we'll just check we've got earth continuity and I haven't messed anything up. So I've got earth there on the plug. Okay, so we've got earth there. So that means that little flying lead was only to earth the front plate here, and as we saw, it came off a junction box, so it's earthed even without that. Obviously once we put that main plate back on and it's running for real, I'll connect that earth back up again. For now we can control the speed of this potentiometer, so that'll just be 0 to 10 volts and then a read off. So we'll set that, I don't know, kind of modest speed for now. And then I think the only thing we need to put on then is the belt, and then we can run it. Oh, in case you were wondering, the little connectors I use were these are the Wago ones. I bought a kit of these quite a long time ago and found them really handy. So you just push to connect. Some of them are sort of to join. That's obviously just isolates one on its own, so you saw me use 2 of those. Or you can join 4 together. All the different colours tell you how many you can join, so there's 2 there and so on. And then there's this type here, so this is sort of push. You can get them out, but if you want to take things in and out a lot, then you've got this lever type where you just leave that up, put the wire in, push it back down, so you can reuse those. So I've got 2, a 6-way, yeah, sorry, going out frame there, 2 and a 6-way, 3-way, yeah, and a bunch of these, so really handy. Yeah, if you've got little joining jobs like this, perfect. I think maybe about £25, £30, so not too bad, and you know, do last a long time. So really rate these, really good. Okay, so the belt's back on. As you can see, I haven't bothered putting the main plate on because that just went up to the other slave idler and then the tensioner things, which isn't used in this configuration. Also the lockout switch, obviously I've shorted that out now, so that will always be on. So quite like this stripped back look. Obviously the plate will have to go on in some form because there's another sort of stud like that holds the end plate on, or the cover on, or I'll have to drill another hole or work something out, or machine a very small piece just to fix that stud onto, something like that, I don't know. Or maybe I'll just put it back on, that's going to be easier. Right, so in theory that should run, and if I've done my wiring correctly it shouldn't go bang. Looks good, sounds good. Looking good down here. And then there's quite a bit of air coming out there. I wish that's going to run a lot better without that cover on. So a lot of that noise you can hear is there's a fan, a mains powered fan behind this motor, and it's blowing the cool air across it. It's cool. Okay, let's see if it starts. Here we go. Yes. Well, so I don't know what speed I'm doing, but I can guess that's about 900. I probably want to come down a little bit, but it works. Okay, so in order to get that to fit, I need to desolder this little through connector on there, DuPont connector, so we'll get this set up. And then I might have some luck with this. This is like a solder sucker, so it works on a kind of vacuum idea. And sometimes when you do this, I find anyway, I need to wet it a little bit just to get the solder and the heat to go in. So these are the bits that came with the kit in terms of the display. So these are the things that James made himself. He 3D printed this kind of separator bracket, and then he 3D printed these buttons. I think they're different, aren't they? These maybe Ninja Flex or something like that. So these allow you to push down through the case there and onto these little switches. So that's quite a neat way to do it. And then the other thing he supplied and he made himself is these little screens that make the numbers a little bit more visible, and then he supplied all this hardware as well, so there's some long and short screws there, some little lock nuts, nylocks, and then there was a spare one of these. So actually in total there were 3 of these headers. I think it's 1 spare, I can't see where that would go. So one was to replace the straight ones that come up here, and to be honest I don't know why they supply these with straight ones, because as soon as you want to put this in a box, you know, those pins go straight up. How does that work? Obviously I guess that was much easier for them to make, but I've managed to solder on a new sort of 90-degree header on there, so that one's a spare. Yeah, I think so. We just need to put this together and then see how it's going to fit onto the front plate. Something I noticed just looking at this 3D print, which is fine otherwise, is that these little holes were slightly blocked, so I've just been manually, sorry it's not focusing very well, just cleaning them out. I think they're 3mm. Well, those aren't too bad. It should be a, oh I see that one's catching, there we go. So that's there, and then the other thing I want to do is the board has this protective film on. It's sticking to me, there we go. Alright, that looks nice and fresh now. So the next thing to go on I think is this bit then, isn't it? Oh no, it's this bit first. So that goes on like that. So clay, And that, well, that connector is going to be close there. Alright, we'll see how we go. I might have to file a little bit out of the print. Oh no, it might just about go. Alright, so there's that one. And then I think this must be next. Has that got a cover on as well? Okay, so I don't know if this matters which way around it goes. That looks kind of matte. Same there. Alright, go that way then. That's a nice display there. I think that goes on top. Oop, it's come out of alignment. Maybe we'll get one of the fixings through. Get the diagonal other side. Maybe the top one. And let's see if we can get maybe a nut on the back. Guess to stop it falling apart, I just gently, or the screws falling out, get each one on. And I think these are M3 nylocks. So that's a 6mm socket. Oh, it's not 6, maybe it's 5. It's not 5. Nope. So these nuts are Imperial, brilliant. And the socket is a 7/32. Love it. Okay. I live in the UK and I know a long time ago we had a big hand in developing this system. Although I think it's subtly modified now, the American standard. But Imperial. Luckily, the French came to our rescue. And yeah, we've still got these old Imperial tools over here, but all the engineering is done in metric. Unless you're building something really old, I guess. An old steam engine or something. If you speak to the old machinists, they can machine in either at the moment, but some of the young guys, they just do metric. Alright. So you torque this up to about 80 Newton meters. No. Probably about 3. Or wait till it cracks the plastic. And there's a bit of vibration on the lathe, but being nylock, that shouldn't be a problem. Yeah, I'm good with that. holding it firm. So what do we got? He must have been really proud developing that. Looks really nice. Oh, you just watched me do that, didn't you? Let me put the buttons in. Right, we've got the buttons in this time. Click. Yep, looking very smart. Okay, and there it is. So I finished cutting out the shape, just had to make it a little bit larger down here, and a cutout there for the connector for the display. I've just drilled the 4 holes, and that fits in there quite nicely. Now I know James, he mounted his to a box and then had that on the front of the machine, but I wanted to incorporate it and integrate it if I could, and I think that's going to work quite well. Now the hardware he supplied, I just measured it, it was 3.3 millimeters or something, so it's probably Imperial again. So I've got some good old M3s in here, and so we'll just screw each of those in. Now one of the things I noticed actually to my advantage is the 3D print of the spacer bit sits in the corner and then there's nothing here, so actually it's going to fit quite nicely onto a curved surface without any kind of infill piece or anything like that. Now I'll do these up, but one of the things I'm a bit worried about is when I mount this onto the machine, it will pull this into its final curve, so the machine's actually more curved than this, so I'll just have to watch out that it's not going to put too much load on here. So we'll just gently offer it up and see what it looks like. But there, that looks pretty smart. Pleased with that. Okay, I'm starting to put this back together then. So we've just got the potentiometer on, and you can see the displays in there quite nicely. That's tight, so we'll put the main control knob on now. Just make sure that's at minimum. Not sure that earth's so important now because I haven't got mains in here. It's just got the 10 volts for the potentiometer, but we'll put it on anyway. Right, so let's see what we've got. finishing touch. I was wondering if this is going to be stiff enough here when you push these buttons, but yeah, I think this is actually stiffening it up, and it spans all the way across to the edges anyway. Looks like it was meant to be. Very nice. Pleased with that. Now obviously it's got to come off again to get that connector in, but yeah, looking good. Okay, so here's the little encoder bracket we made earlier, and then the little standoffs, and I've got the screws as well. Now the pulley, this is just a scrap piece I've turned up just to sort of see how it's going to fit. The actual pulley, that's a T5 with 40 teeth, it hasn't arrived yet. I've just had notification it's going to be another couple of weeks, so I'll wait till that arrives, because that'll determine exactly where these get drilled and tapped into here. So I don't want to guess. I'd rather that was here. And then also there's a couple of little belts that I had. Let me just show you those. So my idea was these little T5 belts go onto that gear directly. So that's an involute gear, just a regular gear, and then these belts, the T5 and a HTD, are all based on an involute design, and it's actually a beautiful fit on there. So I've got the, oh no, I haven't got the belt on, that's okay, I can run that. As you can see, that is a really nice fit on there. It engages wonderfully, so that's a nice easy solution to that. It's only driving, I can get it off here. It's only driving this little pulley, and there's no real resistance to that at all, so I think that'll be absolutely fine. So effectively that will go on there, and then you can imagine that will go like that, and then the belt will go around the pulley, and then they'll sort of sit about there, somewhere like that. And then there'll be the slots for the adjustment. Now, I can't come too far because I've got to watch out because the lid will be here, but looks like that's going to fit. So that's where we're up to. Yeah, so I'm really pleased with how that turns out. It looks quite nice. It looks like it was meant to be there. Still use all the other controls, and I've tidied up the wiring a bit in there. Feel a bit happy with that. And yeah, I've got a nice solution for how I'm going to drive the encoder just with the T5 belt, just direct off that gear there. So I've just got to wait for the correct T5 pulley to arrive, and then we can get that drilled and tapped into there, and then that'll be that sorted out. Still waiting for the servo to arrive. That might be within a few days time, so maybe that'll be the next job. So I think I'm going to mount it on the side here and then cut a hole in the side of the case rather than have it stuck out the front here, which I think probably isn't going to be look quite as good. Yeah, so as always, thank you very much for watching. Hope you've enjoyed, and see you next time.